Hello students, so here we are solving some problems of graph of linear equation, isn't it? Let me put on this nicely. Alright, so let us have a look here. What it tells you, the question we have done a little bit of graph inputs in a video before this. So now we are coming for the numericals. A body starts from rest, so that means it's here. Time 0 and distance 0. And it changes its velocity to 72 kilometers per hour. That means this is 72 kilometers per hour. Alright, which means, first let us change, 72 kilometers per hour will be 72 into 5 by 18. So this is 20 meter per second. This we have to remember, or we can write here in bracket 20 meter per second, because hopefully time is in seconds. Yeah, in 10 seconds, yes. So time is in seconds. So here we have 10 seconds. Time in seconds, it's already written. Now we plot this on a graph, 10 second and 72. So now the graph is made. I will need a scale. Just a second for you all. My ready-made scale is here. So I join this with the use of scale. Let us keep our work neat. We join these two lines. Let us see. So we have joined these two lines. Now see what will happen. Let us have a look. Now this is 72 kilometer per hour, that is 20 meter per second, and this time is 10 seconds. So now I said, how do we get acceleration? How do we get acceleration? Acceleration is obtained by the slope. So that means slope means we have to complete a triangle. So this triangle will be completed now. And the slope of this triangle will give us the acceleration. So acceleration will be slope perpendicular, that is 72 kilometer per hour, but time is in seconds. So we will select this perpendicular by base. So 20 by 10. That is 2 meter per second square, because the unit of acceleration is meter per second. Again have a look. We plotted it here. It started from rest, so I put it 0, time 0, speed. And now 72 kilometer per hour. It reached in 10 seconds. So I have to take this point, 72 kilometer per hour, 10 seconds. So after plotting, you drop a perpendicular, and then perpendicular by base will be the acceleration. Now distance covered is very simple, area of the graph. So distance covered, area of the graph. That means half base is 10 and height is 20. Sometimes you will forget to change the unit, that's not good. Time in seconds, so we should have meter per second, not 2 tens. So that means it has gone 100 meters. So this is the first question finished. Now let us go for the second question. Right, so I change this. I just remove this one. We don't need this. We don't need, and let us go there. And we keep the graph intact. So this is 0. Now it is telling a body changes its velocity from 54 kilometer per hour. So 54 kilometer per hour will be how much? 54 into 5 by 18, that is 15 meter per second. And let us see the other one, 108 kilometer per hour. 108 kilometer per hour, 5 by 18, 6 times, so 30 meter per second. So now we have to plot this on a graph. So we can take, imagining that, okay, this is 15 meter per second. You don't have to be very accurate while solving the numerical on graph. You can use your own adjustments. So I place it 13 and in 6 seconds. So 6 seconds is here. So let us see, in 6 seconds the body comes from here to here. So now this is actually the graph you will have plot. Now you have to find out. Now you have to find out the acceleration. Acceleration means slope. So let us try the slope here. what we do, let me draw it little neat for you all. Okay. Now slope means I have to make a triangle, so I drop a perpendicular, and then from here where its velocity starts, initial velocity I drop. Now it's very easy. The slope will be perpendicular. So acceleration is given by slope, and slope means perpendicular by base. So this part length we have to know. So from here to here it's 15, from here to here it is 30. So 30 minus 15 is 15, and the time here is how many seconds? Let us see. In 6 seconds. So this is 2.5 meter per second square is acceleration. And now distance covered is easy. Area of the graph. Distance is in when we have velocity time graph, we can find out two things: acceleration through slope and distance covered through the area of the graph. So first this rectangle 15 into 6, and then the triangle on the top. So half, base is 6 and height is 15. So this will be 90 plus 45. So 135 meters. So this is also done. So good. Now we go to the next question. Next question. A body traveling with a velocity of 50 meter per second. meter per second. Now what will happen? It is traveling already with a velocity of 50 meter per second, and brakes are applied, and comes to rest in 10 seconds. Okay, so it has come here after 10 seconds. So it is retarding. So the graph is like this. So now retardation is the slope. Slope will give the retardation. So slope will be equal to perpendicular, I will write it, retardation. So 50 perpendicular by base, 10. So it is 5 meter per second square. If you would have called it A, if you were to write what is the acceleration, so it will be negative 5 meter per second. Retardation means already negative have put it, it is slowing down. But if you have not put it retardation, then A is equal to negative minus 5 centimeter per square. And then the last question, when we are coming over here, is one of the best. It will cover everything. So let us go there. So what does it say? We have to read nicely. A body starts from rest to attain a final velocity of 40 meter per second in its first 10 seconds. Okay. So let us see. Now what is happening? In the first 10 seconds, it attained a velocity of 40 meter per second. It attained a velocity of 40 meter per second in first 10 seconds. Okay, from till here it is 10. Okay, time in seconds. Now it travels with this velocity. So I can draw this graph here only. Now for the next, now it travels without any acceleration. for the next 50 seconds. Okay, that means no acceleration, means this will be parallel. No, the velocity does not increase, time increase, and the body is going in uniform motion for 50 seconds. You don't have to use the exact scale when you are doing. You can tell, okay, till here it is 50, so 10 plus 50, this is 60 seconds. And then brakes are applied and body comes to rest in 5 seconds, right? So this is 65 seconds. Now we can easily find out whatever is said. So let us have a look. So now from here you can go through this question. A body starts from rest, attains a maximum velocity of 40 meter per second in 10 seconds. So it was accelerating, then uniform velocity it came for next 50 seconds, then it was retarding. Though it looks, I can make it little reasonably accurate. 5 seconds will be little lesser than 10 seconds. Okay, let us see this. So this is 60 seconds, and this is 65 seconds. So it's now more or less accurate. So acceleration will be very simple. Acceleration, they are telling, find perpendicular by base, because slope of velocity time graph will give acceleration, so it's easy. So it will be 4 meter per second square. Then retardation, so R. When I use R retardation, then see this, the perpendicular is still 40 and the time taken is 5. So it is 8 meter per second square. If I write it A, then it will be negative 8. Now they are telling what is the distance covered while accelerating. So only this part area you take out, because area of the graph gives distance covered. So this was the first part A, this was the B part answer, then C part will be distance covered. So distance covered while accelerating, will be half base 10 into height 40. So this will be 400 by 200 meters. Distance covered while retarding, will be equal to, this is distance retard. So distance covered while retarding, it will be half, base is 5 here and perpendicular is 40. So I am basically using this area. So how much is this? 100 meter. Suppose they would have told total distance covered. So we have got this as 200, we have got this as 100, and this is 50, 60 minus 10. So this length is 50 into 40. So this will be how much? 50 into 40 is how much? 2000. So total distance covered will be 2000 plus 200 plus 100. That means 2300 meters. Thank you.